Have you ever thought about this question? Why do utility poles, transformers, and even electric trains rely on insulators? With this question in mind, we conducted a simulation experiment. Suppose we remove it at this moment. The current would flow through the entire object. This would lead to serious consequences. Now let's further understand insulators. If we simply replace the insulator with wood, electricity can easily leak. This is called arcing. At best, it produces sparks. In severe cases, it can even cause a fire. The solution is to install an insulator here. It is placed between the wire and the conductor. Although the wire and conductor are perfectly separated at this point, there is still a problem here. A bird's eye view shows that an electric field line is generated during power transmission. It is roughly distributed like this. It's just that it's invisible to the naked eye. It can pass through the insulator into the air. As we all know, arcing occurs through the air. We need to understand the distribution of the electric field in the air. This is the distance between air molecules. The focus is on the difference between the electric fields at point A. The focus is on the difference between the electric fields at point A and point B. Although the electric field strengths at both points are the same, the density of the electric field at point A is clearly greater than at point B. The conclusion is that the force at point A is greater than at point B. Therefore, point A is more prone to arcing phenomena. This means that this part of the insulator on the cylinder is a high-risk area for arcing phenomena. In fact, the solution is quite simple. We just need to add a disc at this part of the insulator. Now let's observe again from a God's eye view. It is clear that the electric field lines here are already very sparse. Isn't it obvious when compared to before? This design can significantly reduce the likelihood of arcing. But it is not perfect either. When encountering thunderstorms, rainwater can flow from the insulator's cap to the conductor. How should we address such issues? In fact, an umbrella serves as a great visual reminder. After careful consideration, based on this, scientists modified the design of the disc. It's this shape now. It can not only reduce the likelihood of arcing, but it can also effectively prevent the occurrence of conductive phenomena in water pathways. Of course, we can also add more discs based on local conditions.